What's up, you freaking geniuses? So in this video, I'm going to teach you how to evaluate trig functions using reference angles. So we don't need a calculator for this, all right? So there's several different ways we can do this. The method I'm going to show you here, you need to know at least the first quadrant of the unit circle, all right? So I put a big one over here that we can refer back to, but in case you need help memorizing the unit circle, I'll link a video to that in the description below. But for this video, I'm going to assume that you're familiar with, or at least know how to come up with the values for the first quadrant of the unit circle, all right? So let's start with this first example right here. So we want to find the cosine of 4 pi over 3. Now, whenever I'm given an angle in radians, I normally like to convert it into degrees just because it's a little more intuitive and it's a little bit easier to draw, right? So in order to convert radians to degrees, all you have to do is multiply by 180 over pi. All right, so if we multiply these two together, you can see we have a pi on top and the bottom, so those cancel out. And also we essentially have 18 over 3, which reduces down to 6 over 1. All right, so now if we multiply these together, on top we have 4 times 60, which is equal to 240. And on the bottom we simply have a 1, right? So we can divide by 1, which won't change our answer. So our answer is simply 240 degrees, right? So the first thing that we have to do here is just draw this angle, right? So if we draw some axes here, and we label this as 0, 90, 180, 270, and if we go all the way around, that's 360, right? So 240, let's see, starting from standard position, we're going to rotate this way, right? So 240 is going to be about here, a little bit before 270. 240 degrees. All right, now that we drew our angle, the next thing we have to do is find the reference angle, all right? So that's simply going to be the shortest distance from this angle that we just drew to the x-axis. So the shortest distance from this to the x-axis would be this distance right here, right? This is what's known as the reference angle, also noted as theta prime. Okay, so what is this distance right here? Well, to get from 180 to 240, that's a difference of 60 degrees, right? And notice that the angle is positive because reference angles are always positive, all right? So what the hell does this mean? So this is telling us that we can relate this 240 degree angle to the first quadrant as a 60 degree angle, all right? So knowing that, we can look at our first quadrant of the unit circle, and we want to look at 60 degrees, all right? So 60 degrees is right here, right? In radians, it's pi over 3, and we have the coordinate pair right there. Okay, so right now, instead of looking for the cosine of 4 pi over 3, which is the same thing as the cosine of 240 degrees, what we can do is look for the cosine of 60 degrees, all right? We want to look for the cosine of 60 degrees. And the cosine and sine you can get from the coordinate pair right here. So the x coordinate and the y coordinate that we have written right here are related as cosine and sine. All right, so the x coordinate is the cosine and the y coordinate is the sine. Okay, so if I'm asking what is the cosine of 60 degrees, I'm asking what is the x coordinate at 60 degrees. And the x-coordinate, as you can see, is positive 1/2. So let's write that down here for reference. The cosine of 60 degrees is equal to positive 1/2, right? So that means the cosine of 240 degrees, let's write it down here, the cosine of 240 degrees is also equal to 1/2. The only thing that we have to do is figure out if this is also positive or if it's actually negative. And the way that you figure that out is by simply looking at your quadrants, the signs in each quadrant. So this is quadrant 1, right? This is quadrant 2. This is, let's write it over here to the side, quadrant 3, and this is quadrant 4. So here in quadrant 1, when we're looking at the xy coordinates, both the xy coordinates are positive, right? In quadrant 2, the xy coordinates are negative positive, right? And in quadrant 3, let's just write it over here, the xy coordinates are both negative, right? Negative, negative. So in quadrant 3, since all the x coordinates are negative, and again, we know that cosine just means it's an x coordinate, that means the cosine of 240 degrees is equal to negative 1/2. Boom. All right, now for this last example, we're going to find the tangent of negative 210 degrees. So this is conveniently already in degrees, so the first thing we can do is simply graph this angle. All right, so now if we want to graph negative 210 degrees, again, we're just going to start right here at standard position, and then we're going to rotate in the negative direction this time. So this is 90, that's 180, and then to get from 180 to 210, that's another 30 degrees, right? So we'll go another 30 degrees right there. So about there. All right, so this is again negative 210 degrees. And what we want to find here again is the reference angle. So again, that's the shortest distance from this angle that we drew to the x-axis. So you can see part of it's actually already here. It would be this distance right here, right? This is theta prime, the reference angle. So what is this angle right here? Let's see, we know that to get from halfway around here, this is 180 degrees, and then to get from 180 to 210, that was another 30 degrees. So that would also mean that this angle up here must be 150 degrees. Okay, so this angle right here, we can say it's negative 210 degrees, or if we went in the positive direction, we could say it's positive 150 degrees, right? Let's just write that for reference. In any case, what we want to do is, now that we know the reference angle, we want to refer now back to the first quadrant, right? So it's telling us that this angle that we just drew, we can refer it back to the first quadrant as a 30-degree angle. So looking at the first quadrant, we want to look at 30 degrees, which is in yellow over here, right? Pi over 6, if we're talking about radians. But what we want to look at, again, are the coordinates right here. So again, this is our x-coordinate. This is our y-coordinate, right? So this is our cosine, and this is our sine. So the problem is asking us for the tangent. And a very, very helpful formula that you should remember for the tangent is that the tangent is equal to the y over the x. Or y, again, we know is the sine, right? So this is the same thing as the sine over the x-coordinate, which is the cosine, right? So if we fill this in, the tangent of specifically what we're looking at is 30 degrees right here. So this is going to be equal to the y-coordinate goes on top. So 1/2 goes on top, and we're going to divide that by the cosine, which is root 3 over 2. Okay, so let's divide these two. Now, in order to divide fractions, you can just multiply by the reciprocal, right? So that means we're going to leave the first fraction that's on top as is, so that's positive 1/2, and then we're going to multiply by the bottom fraction, but we're just going to flip it. So instead of root 3 over 2, we're going to write it as 2 over root 3. All right, so now if we multiply these together, you can see we have a 2 on top and bottom, so those cancel out. So then we're left with 1 over the square root of 3. Now, the only problem here is that we have a radical in the denominator, which is not allowed because that makes this irrational. So to rationalize the denominator, we just need to multiply by this square root on the bottom and on the top. All right, so multiplying straight across one more time, on top we get 1 times root 3, which is equal to just root 3. And here, root 3 times root 3 is equal to just 3. Okay, great. So we know what the tangent of 30 degrees is. It's root 3 over 3. But again, we're looking specifically for the tangent of 150 degrees or negative 210 degrees. All right, so this will also be equal to root 3 over 3. The only thing, again, we have to check is the sign, if this is going to be positive or negative. And again, the way we do that is simply by looking at the quadrant that this is in. All right, so if we go to up here, this angle is in quadrant 2. So let's say our xy coordinates are right here. And in quadrant 2, the x coordinate, again, is negative, and the y is positive. And once again, We know that the tangent is defined as y over x, the y coordinate over the x coordinate, right? So in quadrant 2, the y coordinate is positive and the x coordinate is negative. So we have a positive number divided by a negative number, which is a negative number. Okay, so the tangent of any number that's in quadrant 2 is going to be negative. All right, so that means the tangent of this angle is negative. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.